Hey, good evening. This is Jim from Mooker.com. Join the forum for more discussion and experiments and builds like this to see where they lead. Okay, let me read you a quote down here first. There is no known material that can completely resist the expansion force of freezing water if the water is contained within it. Ice will expand as it freezes. And if the container is strong enough to resist the expansion, the pressure inside will continue to build until the container fails or deforms. So no known material can completely restrain the expansion of ice without eventually breaking or deforming. What is this saying? It is saying that the pressure or the potential pressure or the potential torque of water expanding when it changes to ice is unstoppable or unlimited and only governed by the material that is constraining it or resisting it. But it will expand under any condition. Nothing can stop its expansion. And it is also known fact that the temperature to freeze water and turn it into ice will never change, regardless of how much pressure there is constraining it. So therefore, we have a finite input level, which isn't really that much to maintain a little box under 32 degrees Fahrenheit. I mean, you're talking like 20, 30 watts. You could keep a little box at freezing temperature. And the output can be as strong as the material allows you to harvest. Okay, but there are some nuances with this technique, which I haven't really found any other sites or videos of people experimenting with this, but I did perform one and I want to present these results. And if you're interested, again, join the forum because I'm going to be doing more. So first of all, I took a balloon and I filled it with 30 milliliters of water from the tap. According to my calculations, water expands around 9%. Okay, so I should see 2.7 milliliters of expansion on the syringe if I would capture 100% of the expansion. Now, I put the balloon inside a plastic tube that could slightly expand, so it has some air gaps around it, so it's not pressing against the sides. And I slid it all into a 60 milliliter syringe. I then got some old cooking oil that was used and I was going to discard, so I filtered some of it and I filled it around the balloon. So the syringe has an oil jacket around the water balloon in the syringe. So the balloon could freeze and it could expand in all directions, pushing the oil, which will push the plunger up. And finally, I jabbed a piece of rubber into the needle to close the needle end, so all the pressure that builds from the expanding ice will force the plunger up. And then we could take some measurements. So here's a close-up of the syringe when it was put into the freezer. We're just about at the 55 milliliter mark. Okay, I left it in there for roughly 2 hours, a little less, until it was done expanding. And at that point, when I took it out, it was 57 and a hair. So we got 2 milliliters of expansion. The maximum I could have got, according to my calculations, as I said, was 2.7. I got about 2. So that means I captured roughly 74% of the possible expansion I was able to harness and capture and turn into direct linear movement. After I took it out, I let it cool and melt a while. Then I checked again and it was back to the starting point at 55. So the results are promising. Now, there were a couple factors I could not control, such as the material of the balloon, the material of the sleeve that the balloon is in, the expansion of the syringe itself. If it did expand, I couldn't control. Well, I could have controlled, but I didn't. The impurities and maybe water vapor that was in the used cooking oil, it wasn't like the best choice to use, but it was just a little experiment. Anyway, regardless of these factors, the results are quite promising. Even though it's only 2 milliliters of movement, the force behind this cannot be stopped, as we just read. This will expand this much, even if I had hundreds of pounds or thousands of pounds against it, restraining it. It can't be stopped. Either the syringe is going to blow out, or the balloon is going to pop, which it won't, or something will fail, or the syringe will crack. But it will. You cannot stop the expansion. So the 2 milliliters doesn't sound like a lot, but because it has so much pressure behind it, you could transform it. Okay, so basically this plunger could push a cantilever with a 10% or 10 times gain on the other side, and make that 2 milliliters into 20 milliliters. And then a 20 milliliters could power a Scotch yoke or a device that transforms it into rotation, and then is geared to get higher speed rotation and whatnot. And the object is to see how much mechanical energy can be tapped out of this little amount of movement, knowing that we have virtually unlimited force that is only governed by the materials that we use. Again, I haven't seen any other experiments toying around with this, so I do plan to next build a Peltier cooler which could heat and cool this syringe from 32 degrees to 35 degrees back and forth to let it melt and freeze and melt and freeze, so that plunger makes a reciprocating motion over time, which pushes on cantilevers, which then changes it into rotation or harvests the movement to see what we could get out of it, how much we could strain it. Now, of course, the proper build wouldn't use a little plastic veterinarian syringe. It would probably use like a hydraulic piston from a tractor or something like that that could withstand, tens of thousands of pounds of force. But right now, this is just to get the data to see the optimization and the build and how everything works. But so far, we're off to a pretty good start, because we did verify we could catch and harvest a large percentage of the possible movement through a plunger arm. So anyway, join the forum and let's see what happens with these experiments. Thank you.